The best way to understand loops is to think about in a repetitive structure or repeating structure. Let me give you an example, and we will dive into this code in a while. The example is, let's say user gives you a number, let's say integer number, and you want to print all the numbers till that number. Let's say you start from 1 and you keep on moving and printing all the numbers as long as you reach that number. So for example, if user enters, let's say 5, your goal is to print 1, then print 2, then print 3, then print 4, and then stops. Then stop, just stop. Or let's say if user if user enter, let's say 3, then you print 1, you print 2, and then you stop. This is easy. If user enters an n, we can just print, we could have written this thing, print I. Let's initialize a variable I with 1, print I, and then I equals to I plus 1, or in Python we can write this quickly as I plus equals to 1. That means that means in I store I plus 1. This is the short form of writing this. And then after that you just apply an if condition. For example, here you can apply an if condition and say, okay, if I is smaller than n, you keep on printing, and after printing you just increment again this, then check the if condition and keep on moving. Well, that is feasible if n is 5 or n is 3. What if n is, let's say, 50,000? I mean, you're writing all that structure again and again and again. I mean, that's a whole lot of code. Well, the loops are just a solution of this kind of structure. When you want to perform same kind of task again and again, the loop gives you the facility to do that. For example, let's just consider a while loop. This is again a condition similar like a condition in if condition. Like in if condition, you evaluate this Boolean expression. That's an expression that results a Boolean value. While this condition is true, you will stay in this block. And after executing whole block once, you check this condition again. If this condition is again true, you will dive into this block again, then check the condition, dive into the block, then check the condition, dive into the block. As long as this condition stays true, you stay in the block, you move inside the block. Once this condition is false, then you exit this while loop, then the loop terminates and you move on to the further processing. Just like in if condition, just like if conditions, if the condition becomes false, you exit that if condition and you go moved on. So in this particular case, for example, if n is 5, let's say if n is 5, user give an integer number that is 5. I is equal to 1. Now 1 is smaller than 5. The condition is true. You move inside. You print I. The value of I is 1. So that's what you print. You print 1. Then you change I. You increment I with 1. That means I equals I plus 1. So I becomes 2. Now the body of the loop finishes. That's whole body of the loop. The body of the loop can have many statements, a whole block of code. Once I becomes 2, you move on and you check, okay, 2 is smaller than 5. Yes, it is true. You move inside the block again. You print 2. Then you update I. The loop body finishes. Once the loop body finishes, you go and check the condition again, whether that condition is still true or not. It is still true. The I is 3. 3 is smaller than 5. Yes, you move inside. You print 3. You update I. You check the condition. 4 is smaller than 5. Yes, you move inside. You print 4. And then you update I. And then you move on. Now 5 is smaller than 5. False. Once the condition is false, you will not dive into the body of the loop. You will exit the loop and you will print done. And that's it. Done. So this loop becomes very handy in applications that have repetitive structures, and in most of the interesting programs, most of the interesting problems, these are the loops that play a very huge role. So let's go to Jupyter just to get our hands on this loop. For example, let's say x is again, let's say int or n. Let's take n. N is int input. Let me make this a little bigger, just to, let's say that input, and input is a number. Let's say n. I is your certain let's say 1, while I is smaller than n. You may have written this parenthesis just to create the readability, just to make the readability, and otherwise, I mean, this is also okay. That's perfectly fine. As long as I is smaller than n, keep doing the following. What you do is print, for example, the square of I. Print the square of I. That's the square of I, let's say, and then you say print, for example, this is iteration number, and then you just print I. That's the iteration number I of the loop. That's the iteration number I. This is just a string. This is just a string, and that's a variable. Its value will be printed. This print function takes as many arguments as you pass. So you can write a comma here and continue whatever you want to print. That's a very flexible function. Okay, then what you do, you say, okay, I plus equals to 1. By the way, this I plus equals to 1 is the same as I equals I plus 1. You see, I have just commented here just to explain what this is doing. If I just write I equals I plus 1, that is also correct in Python, but that's kind of a shorthand. Okay, and that's it. Now again, when I de-indent, I'm outside the loop. This is print loop done, for example. So that's the code, for example. So let's run this code. For example, let's say n is equal to 5, then we have 5, so this is 1, this is the iteration number 1, then 2 square is 4, this is the iteration number 2, then 3 square is 9, the iteration number 3, then 4 square is 16, this is the iteration number 4, and then the loop finishes. That's it. That's a first snapshot of the loop. We'll continue from here onwards in the next video, and I will show you more and more flavors of this loop. So hold on and wait for the next video. Okay, in the previous video we saw while loop, and we saw one program related to while loop, just printing a bunch of numbers till a particular number. Well, when you are inside the body of the loop, that's a whole new, you can write whatever you want to write. For example, you can apply an if condition inside the body and check that at each iteration a particular decision should be made or not. For example, in this particular case, I'm going to print I whenever I is an even number. So I is some number. If it is even, then print it, else pass. This pass statement, for example, is just a statement of saying that do nothing. It is just a shortcut of writing do nothing. We could have omitted the whole else part along with this pass, and still the code is equivalent. But sometimes writing this pass make the code readable. Just so writing this pass statement just means do nothing and just move on. If we omit else statement and we omit this parse, that's perfectly okay. So for example, let's try run this code. Let's say n is 5, I equals 1, 1 is less than 5, yes, 1 is not an even number, so go to else part. Else means pause, which means go on, and then increment I. This print statement is outside the loop. This is aligned with this while. This is not inside the body of the loop, otherwise it should have been indented inside. Now I is incremented, I becomes 2. Now move back, 2 is smaller than 5, yes. 2, remainder 2 is 0, yes, so print 2, so 2 will be printed. Because if executed, else will not execute, and I will increment, because I is not inside the if condition, it is inside the body of the loop. So I incremented, I becomes 3, you go back, 3 is smaller than 5, yes, 3 remainder with 2 is 0, false, so pass. I plus 1, so I becomes 4. 4 is smaller than 5, yes, 4 remainder 2 is 0, yes, so print 4. So else will not execute. Now increment I. Once you increment I, you get, for example, I equals 5. Now 5 is smaller than 5, false, so you go out of the loop and you print done, and that's what this code is. So you can have if condition inside the loop, you can have nested if inside the loop, you can have loop inside the loop, nested loops. We will see examples of nested loops as well. I mean, that's all allowed, or sometimes really required. Okay, so next there are two important statements that are there. One is break, one is continue. I want to focus these statements because they have a deep link with loops. A break statement, wherever written inside the body of the loop, tells that exit the loop immediately. Whenever this break is encountered, whenever this break executes, it exits the loop immediately and brings you outside the body of the loop. That's what it does. Break. So for example, if I becomes divisible by 17 and the remainder becomes 0, you will print a break. And then when this break statement will execute, you will exit the loop immediately, regardless of what is the value of I, what are other states, whatever. Break exits the loop. Okay, great. Now the continue. Continue statements. Continue statement wherever encountered. Continue brings the next iteration loaded, regardless of the remaining statements in the loop. For example, when this continue will be executed, no matter how many statements are there onwards that are there in the body of the loop will not finish its iteration by going through all the remaining statements, but it will start another iteration immediately. So continue basically skips the remaining body of the loop and starts another iteration. Here I have written this true. True means while true means always run. You might be thinking always run, it's an infinite loop. Will it when we will exit the loop, because this true statement will always stay true. We're not changing this true anymore. There is no condition here. That's true. While true means always go inside the loop. But whenever this break is encountered, you are outside the loop right away. And this break exits the loop. This continue skips the remaining portion of the loop body and starts the new iteration, starts another iteration. So this continue means start another iteration immediately, skip the rest of the statements. So rest of the statements inside the loop body. Okay, so let's just practice this break and continue just in Jupyter Notebook to get a better look and feel of the loop. So let's say we have, let's say n equals, let's say 10, or we might have taken that as an input. Let's say n is equal to 10 while true, which means keep moving. We might have taken some value here, I equals, let's say 1, while true, if I remainder with, let's say 9, if that is equal to 0, then just break the loop. else 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 what you do is really you increment else what you do is if I is if I is not divisible by 9, then what you do is I equals I plus 1. That's true. By the way, previously we have written this way, so either way is fine, whether you write a short form or this form. So else this. Okay, and that's it. The loop finishes. That's the loop. After the loop, you just write okay, print the loop is done. So let's see what's the output. The output is done straight away, and the reason is well, why it is, oh, 1 is divisible by 9, only then you could have break. While true, why the loop, oh, it does not print anything. We could have printed some statements so that we know that we went inside the loop or not. Okay, so inside if, so for example, print inside else. So let's run this again. Oh, okay, great. Inside else, inside else, inside else, inside else. The first time it go inside if, that time it breaks and it goes out and prints done. That's what this break statement does. So let's see an application of continue statement. Let's, for example, just copy and paste that code into another cell and see how this continue works. So let's say we have a loop like so. So what we say is like this: if I is 9 is not equal to 0, if this is the case, if I is not divisible by 9, what you do is you take I plus equals to 1 and then continue to the next statement, and whatever else you write here, for example, print something, print something else, whatever, that will not be printed, and once the continue will be encountered. Whenever this I is whenever this I divisible by 9 is not true, if I is, then you continue. Once this I is divisible by 9, for example, then you will not dive into this if condition. Only then these two statements will be printed, because this continue will not allow anything further that should happen. And once these are printed, let's say we break our loop right there, let's say. So if, for example, for the very first time 1 is not divisible by 9, so I equals 2, so continue, these three statements will not be executed, the next loop, the next loop, the next loop. Once this if condition becomes false, this continue will not operate, and then we print this statement, then only then we will print this statement, and only then we will break and we'll exit the loop and print the done. So let's print here, print inside if. So let's run this code. Let's run this code and see what happens. That's the code. Maybe I should just, yeah, that's a better font. Let's run this code. So when the code is run inside if, inside if, inside if, you see when you are inside if, when you continue, when this is the body of the if condition, when if condition completes, it should print these two things, but continue is telling the cursor to go back to the next iteration and move on. And once this if condition becomes false, only then you get this thing printed, this thing printed. If this break was not there, you then again was going to the while loop, and you will be running an infinite loop, and then you have done. So that's what this continue and break does. So in the very next video, we will see another kind of loop. Here we saw the while loop. In the next video, we will see a for loop, very powerful and very famous kind of loop. For it does almost the same stuff as while loop. While the while loop runs based on a condition, the for loop, it runs based on counter. It's a counter loop that many times it should run, and so on. So we will see the details of for loop and the applications of for loop in the next video. Hope to see you in the next video.